last one of these types of problems that we're going to be looking at tonight. So again, not using our calculator for this, we want to name the critical numbers of f of x. So the critical numbers, once again, are when f prime of x equals 0 or undefined. And it's going to be 0, f prime of x equals 0 for x equals negative 3 and 2. If we plug it in there, my derivative is going to be 0. And f prime of x is undefined for x equals negative 5, because if I put negative 5 in there, we'd be divided by 0. So the critical numbers are x equals negative 5, negative 3, and 2. So these are the critical numbers for my function f of x. The next question is, for what values is the original function increasing? So it's increasing when f prime of x equals, well, when f prime of x is greater than 0. Because remember, that means that the slopes of the tangent line are positive, and if that's true, then f of x is increasing. So in order to do this, the easiest way to answer this question, provided that you have a good understanding of graphing rational functions and well, graphing in general, the easiest way to do this is just to make a sketch of f prime of x. And to do that, we know that we're going to have a vertical asymptote at x equals negative 5. So let's draw that in. Expanding, well, not expanding, but we know that for f prime of x, the top leading term is going to be x squared. If we were to do x minus 2 times x plus 3, you're going to get x squared leading term. And if we did x minus 5 squared, our leading term also would be x squared. They have the same power. So we know that we're going to have a horizontal asymptote at y equals 1. Here's x equals negative 5. And as far as zeros, we know that when x equals negative 3, you're going to have a 0. And when x equals 2, we're going to have a 0. So filling in this graph, we know that the horizontal asymptote is y equals 1. So from here we can go, starting here we can start at y equals 1. We have a 0 at x equals 2. There's no multiplicity. It's not x minus 2 squared, so we know it's going to cross. We've got another 0 at x equals negative 3. No multiplicity, so it's going to cross again. Those are the only two places that cross the x-axis. Those are the only two places where my derivative function is 0. So then it's going to go, it must go upwards for forever. And then what's going on to the left of x equals negative 5? Well, we could just plug in some number, f prime of some number less than negative 5, like negative 10. And when we plug that in, we get negative 10 minus 2, negative 10 plus 3, all over negative 10 plus 5 squared. And all we care about is the sign of this. So this is going to end up being negative times a negative, all divided by a negative squared. So negative times a negative is positive, divided by a negative squared, which is a positive. We know that my derivative is going to be positive. So given that it's positive, the only thing it can look like is being something like that. So for what values is the original function of f of x increasing? It's really just asking, what we're asking is, when does my derivative function, when is it greater than 0? Because when it's greater than 0, my function is going to be increasing. And the solution to that, where it's greater than 0, let's just draw that in blue, greater than 0. Here it's greater than 0, not greater than 0, greater than So the solution to my problem, for what values is the original function f of x increasing? So for my function to be increasing, my derivative must be greater than 0. That happens for x being from negative infinity up to negative 5, from negative 5 to negative 3, and from 2 to infinity. Now, let me just say, some of you, I imagine, are thinking, wow, how are we supposed to graph these rational functions? That is one of the expectations from pre-calculus, though I will say we will practice this a lot. But familiarity with graphing exponentials, rationals, polynomials, sine, cosine, trig functions, being able to graph these all without a calculator are expectations of the course. So if this is something that's seeming very tricky, it's worth getting some extra help on how to graph functions. But just going back, what we were trying to do is find the values that made the original function of f of x, what values is the original function increasing. And for original function to be increasing, that means that my slopes need to be greater than 0. So I graphed my slope equation, my derivative equation, which is just giving me the slopes of my function. And I looked for when are these values, the blue ones, when are they greater than 0?